Algebra 1, Day 62. Today we're going to be talking about factoring the difference of two squares. So we've been talking about factoring here for about a week, and we've talked about breaking down these complicated polynomials or trinomials and breaking them down into what are essentially multiples, just like we can do with numbers. These help us in finding our x-intercepts, which are our solutions, zeros, roots, um, whatever you want to call them, depending on the situation. So, while this may sound a little bit daunting and scary, it isn't. So, I want to just go ahead and jump right in it, and then I'm going to explain to you what exactly this is. Okay? So, first thing I want to talk about is these perfect square roots. So, these guys mean essentially we're taking every single whole number and we're multiplying it by itself, and we end up with what's a perfect square. So, I usually work these in the backwards way. So, each one of these is essentially taking what we think of as our counting numbers and multiplying it by itself. Now, the only thing that I need to mention about this is that a lot of times people don't remember that whenever I take the square root of something, there's actually two separate answers to that. There's a positive answer and a negative answer. The reason for this is, for example, if I took the square root of 36, you would tell me, oh, it's 6 because 6 times 6 is 36. Yep, that's totally correct. But negative 6 times negative 6 is also 36. So we always have to keep that in mind because that becomes important as we continue our study of quadratics. So I'm going to skip through the steps here and we're going to come back to this at a later time. Or we might not. What instead I want to do is I want to go through some of the problems. I'm going to solve them using our typical factoring method. And then I'm going to go ahead and we're going to take a look at it and figure out what what the pattern is to these guys, okay? All right. So let's go ahead and get started. Let's look at this guy here. And I want to ask myself, well, do they have anything in common? And it looks like they're both multiples of 9, maybe? So let's go ahead and take that 9 out. And everything I see, I'm going to divide by 9. All right. Looks like I can't really get anything else out. So now I'm going to go ahead and that was step one, getting my greatest common factor. Now I'm going to identify my A, my B, and my C. So my A is 9, my B does not exist, so it is a 0, and my C is negative 4. The fact that my B value is 0 is something that's really important. That's critical for us to be able to do this, okay? So let's go ahead and continue forth. A times C, and let's go ahead and multiply those guys together. So I need two numbers that when multiplied together will give me negative 36, but will add together to give me zeros. That means these will be a zero pair. Things like negative 6, positive 6, negative 5, positive 5, negative 20, positive 20. So, uh, my best guess would be negative 6, positive 6. That does multiply together to give me negative 36, and it does add together to give me 0. So those are my numbers. So now I'm going to go ahead and split apart my B term. All right. So now I'm going to go ahead and factor from just the first set of terms. They have a 3x in common. Now I'm going to factor from just my second terms. Looks like they have a 2 in common. All right. Now that I've done that, I do notice that what is on the inside of the parentheses is exactly the same. So I can go ahead and combine my like terms. Okay. So now I have an answer. This is completely factored. However, what I do want to make sure that I'm doing is I also want to figure out what the pattern is here. So I definitely want to make sure that there is some kind of pattern, right? So let's take a look at it. All right. So I'm going to take a look at just, let me go ahead and change my color here. 9x squared minus 4. All right. So if I'm looking at this, I see here that this guy, this 3 is the square root of the 9. And funny enough, these 2's are just a square root of 4 with alternating signs. Very interesting. So that means that the pattern is take the square root of the first number, square root of the second number, split it apart into 2 separate binomials, one with the plus, one with the minus. Okay? So let us verify that this would work here. All right. So for this one, I see that it is a similar setup where I have number x squared minus some other number. For this to work, they've got to be perfect squares. Okay? Remember, those perfect squares are things like 1, 4, 9, 16, 25, 36, etc., etc., etc. So what I'm going to do is first thing is I'm going to write out what I already know. So I know that this is going to be part of my factored out part, okay? Now I'm going to take my very first number. I'm going to take the square root of it. I'm going to write that in, 5 and 5. Now I'm going to go ahead and I'm going to do the same exact thing to the second number. Square root of 256 is 16. All right, so now I have this. Okay, I just want to verify that this is correct, right? We could go ahead and plug this in the calculator. We can graph them to make sure that they're the same. We could go ahead and factor this and go through all the steps to get the same answer. And we can also just plug it into our box. So just as a review, I'm going to go ahead and plug it into my box here. And yes, it matches exactly. Okay, really cool. That means that these problems are super simple to answer. Okay, so let me look at the next one. All right, so I see a x squared minus c. So I'm going to go ahead and write out the parts that I know will always exist in these. And just so you know, just in case this seems a little bit wonky or crazy, these are ones that you can still solve by our traditional factoring method, okay? So I'm going to go ahead and take the square root of that first one, write it in. I'm going to take the square root of my second one, write it in. And just to be extra, I'm going to go ahead and verify that that is correct. So I'm going to put my 2x positive 13 over here outside of my box. Same thing with my second binomial. Let's go ahead and multiply these out. matches exactly. So super quick, super easy, right? Don't let this fool you. Nothing crazy. So we're not even going to go through the steps. We don't necessarily need to remember them. All you need to know is that whenever you see ax squared minus c, and a and c are both perfect squares. Those numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, etc. That is something that we can utilize this difference of perfect squares method on. Okay? This only applies to these kinds of problems. All right, I'll see you guys next time. Have a good rest of your day.